Hello, grade 7s. We are now going to go over section 3.4, which is all about finding the area of a parallelogram. So I actually have really a couple parallelograms in front of us here. So the shape up on top of our grid here is a rectangle, which you recognize, and we have a rectangle that has a height of 1, 2, 3, 4, 5 squares, 5 units, and a width of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 squares. And this is a parallelogram as well as the bottom one because it has opposite sides that are parallel to each other. So this line right here is parallel to this line, and this line right here is parallel to this line. So we can indicate that with our arrows. Same thing with the shape on the bottom. The opposite sides are parallel to each other. So this line here is parallel to the far side. The top and bottom are also parallel to each other. That's what makes it a parallelogram. The sides are parallel. So we're going to be looking at finding the area of a parallelogram. So with our rectangle here, we know that the area of a rectangle is length times by width. We could also call that base times by height. And so for this one, we would say the area is 5 times by 10 is equal to 50, and that would be 50 square units. Let's say that these are centimeters. We'd say 50 centimeters squared if it was 5 centimeters by 10 centimeters. Now, and we could count that here on our grid paper. We could count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 50. And there are 50 squares in our rectangle. So we can actually have a visual here of what those 50 square centimeters looks like. We have 50 little squares inside that box. So we want to find the area of this parallelogram. So if we're thinking in terms of a rectangle, we would say, well, we measure the sides, both sides, so one side and then the top. We can see that the bottom here is, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units across. And well, hey, let's take our ruler, why don't we? And let's measure the side, and we could do that. I'll be as precise as I can. 0 there. Okay, it's about, that is at the 6. So it is 6 units, so my ruler's set so that each one is spaced 1 unit apart on the grid. So the side here is actually 6 centimeters, and across is 10 centimeters. So we would think that the area of this parallelogram should then be 6 times by 10 is equal to 60. But let's count out actually how many squares are on our grid paper. So we can actually let's count out all the whole ones that we see. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. These two combined would be 44. Maybe 44, 45, this is almost on 46, 47, 48 is pretty much whole, 49, so we're not near, we're not getting close to 60, but we are actually really close to 50 centimeters squared. And the reason for this is because the area of a parallelogram is not the length times by the width, but we say the area of a parallelogram, and this is really true of a rectangle as well, is the base times by the height. So now we have this shape, which has one side that's 10, and the bottom here would be 10 centimeters as well. The other side's 6, but 6 centimeters is not actually how tall it is. I'm just going to erase all these dots so I can have a clear. 6 centimeters is not actually how tall the parallelogram is. That's just the length of that one side. If we want to look at the height of it, we have to take from our base at the bottom here, this is our base, which is 10 centimeters wide, we have to take a line that goes 90 degrees or perpendicular from our base. So if we go perpendicular from our base and we go up, oh, a little bit squirrely there, what's going on? And we go up from there, that is the height of our parallelogram. So the height of this parallelogram is 1, 2, 3, 4, 5. Again, 5 centimeters. And so the area, which is base times by height, would be 10 centimeters is the base, times by the height, which is 5 centimeters. And that is equal to 50 centimeters squared. So both this rectangle and this parallelogram actually have the same area. They cover the same amount of space each on this grid. Our rectangle, we could say too that we went from our base, which was 10, and we found, well, if we took a line that is perpendicular to that to go to the top of it, that happens to be the same line as the sides of the rectangle, but that would be 5 centimeters as well. So again, the area of the rectangle is also base times by height. So we're just getting a little bit more specific with our terms and measurements here, not looking at just side lengths. There's sometimes going to be measurements that we have to ignore. So let's do a couple of examples of how we find the area of a parallelogram. So what is the area of this shape right here? So we have 3 different measurements, but we only need 2, because we know area of a parallelogram is equal to base times by height. I'm going to say b times by h. So where is our base? Well, we can look here and we can see, okay, well, our base is along the bottom here, and it's 2.5. So area is equal to 2.5 as a base. That's meters. And our height, well, we have the 2 meters along the side here, but that is not what is going perpendicular. We have this line here, this red line, pink line, whatever it looks like, that I'm drawing as green. This little box tells us that it is perpendicular from our base, and it is 1.8 meters, so this is our height. That is the height of this parallelogram. So it's 2.5 meters times by 1.8 meters. So you take your calculator, you say 2.5 times by 1.8 equals 4.5. So the area of this parallelogram would be 4.5 meters squared. Make sure you put in that squared, and we circle around that because that's my answer. So we just have to make sure that there's often going to be information given to you that is not necessary for the question, like that 2 meter mark. Okay, here's another one. Another parallelogram. What is the area of this one? Well, again, we have 3 measurements. We have to figure out which are the 2 that we need. What is our base? What is our height? Now, we have the 6.5 centimeters, which is going across. So it sort of looks like 9.5 centimeters maybe is our height. But the perpendicular line, we're looking really for 2 measurements that are perpendicular to each other. So 9.5 centimeters and 8 centimeters, those are the sides, so we definitely don't want to use those 2 together. And 8 centimeters and 6.5 centimeters, the 8 centimeters and the 6.5 centimeters, those are not perpendicular to each other either. So those are not the 2 measurements we want to use either. So the 2 measurements that we actually want to use here is 9.5 centimeters, which could be the base, and 6.5 centimeters, which is actually, even though it's going sideways, is actually our height. What I could do with this picture, since it's digital, I can actually turn it sideways, just covering up my question. But as I turn it sideways, now we see, yeah, 6.5 centimeters. When looked at it this way, 6.5 centimeters is the height of the parallelogram, and 9.5 centimeters is the base. But they don't always have to be drawn that way or labeled that way. So even here, we would say that the area is equal to base times by height. And how I'm doing the work here right now is how you should do it in your book to show your work. Area is equal to base times by height. I write out my formula. I fill in what I know. So I know the base is 9.5 centimeters. That's the length of the base, or that one side. And then the height, or here the width, but it's fine. It's going 90 degrees to the 9.5 centimeters, is 6.5 centimeters. I use my calculator. I'm going to multiply these together, 9.5 times by 6.5, and I get 61.75 centimeters squared. Okay, so you have to be a little bit careful sometimes with how it's labeled and figuring out what's the base, what's the height, which are the two measurements I need to use. Sometimes there's only two given to you, then it's obvious, but sometimes there's these extra numbers given that you have to filter out and ignore. Okay, one more example and then we're done. So in this example, we have the area of our parallelogram, and we actually have the base, but the height of this parallelogram goes to come down here. That was 90 degrees. The height is unknown. Our height is x. We can use a letter to represent it, a variable. That's x centimeters. What is the height of this parallelogram? Well, we still know that our formula is area is equal to base times by height. So let's fill in what we know. Area is equal to 180. So 180 centimeters squared is equal to base, which is 20, times by height, which is unknown. I guess we could also use an h as our variable. Let's do that. H. Here's our height. So, what is h? Well, there's a few ways that we could figure out what h is. One way is to just guess and check, to say, well, it's 20 times something is equal to 180, so I'm going to try 20 times by 40. Oh, I get 800. That's way too big. 20 times by 3, I only get 60. Let's work our way up. 20 times by 4, I'm getting 80. Let's go a bit bigger than that then. 20 times by 8, I get 160. I'm almost there. 20 times by 9 into my calculator, and I get 180. So just with some guess and check, I just find something. I eventually whittle my way down to an answer by finding ones that are too high, too low, and then slowly finding the right one. Another way you can actually do this is to say, well, if 20 times something is equal to 180, then actually that answer, 180, divided by 20, actually gives us what the height would be. So now we can let's think about that with some smaller numbers. So we think 2 times n, an unknown number, is equal to 6. What is n equal to? Well, we know, because we know our lower multiplication tables, that n is equal to 3. But if I go 6 divided by 2, that is equal to 3. So that tells me the answer. If I can take my answer and divide it by the number that I know that I'm multiplying by, it gives me the other factor, the other number I'm multiplying by. So 180 divided by 20 is equal to, 180 divided by 20 is equal to, well, 18 divided by 2 is 9 with the 0, so it's equal to 90. Or sorry, I'm dividing by 20. Whoops. 180 divided by 20 would just be equal to 9. So I have my answer here. The height of my parallelogram is 9 centimeters, not 9 centimeters squared, just centimeters. And that is about it for parallelograms. So parallelograms are these really just tilted rectangles, and we can find their areas by taking the base, the measurement of one side, and timesing it by the height or the perpendicular distance from that one side to the other side. That is that.